Parkinson's disease affects nearly 10 million people worldwide, and millions more live with the daily challenges of caring for someone with the condition. And here's the biggest question we all want answered. How close are we to a cure? In today's episode, we're going to explore the most promising scientific breakthroughs in the fight against Parkinson's. We'll examine gene therapies, like GDNF, that help the brain repair itself. We'll look at stem cell therapies that aim to replace the very brain cells destroyed by the disease, and uncover how a common cough medicine, Ambroxol, might actually slow or even stop progression. And we'll break down what scientists just discovered about PINK1, a protein that acts like a built-in brain protector. By the end, you'll not only understand where the science stands today, but also how close we really are to stopping Parkinson's in its tracks. Let's start with one of the most exciting frontiers, stem cell therapy. Stem cells are special cells that can transform into almost any other type of cell. Scientists can now guide stem cells to become dopamine-producing neurons, the very cells destroyed by Parkinson's. The idea is simple, but powerful. Transplant these lab-grown cells into the brain and restore its ability to make dopamine. Early trials in Japan, Sweden, and the US have shown encouraging results. Patients tolerated the procedures well, and in some cases, motor function improved. It's still experimental, but the vision is compelling. One day, a single procedure could restore movement by literally replacing what Parkinson's has taken away. Of course, there are challenges. Scientists must ensure the new cells survive long-term, connect properly with existing brain circuits, and don't form tumors. But progress is steady. Within the next decade, stem cell therapy could move from experimental to mainstream. For seniors living with Parkinson's today, this research offers hope that the future may hold not just symptom control, but actual restoration of lost function. Next, let's look at a discovery that made headlines just recently: PINK1. PINK1 is a protein found inside cells. Its job is to keep mitochondria, the cell's tiny power plants, healthy. When mitochondria fail, cells lose energy and die. In fact, mutations in the PINK1 gene are one cause of early-onset Parkinson's. For years, scientists knew PINK1 was important, but they didn't fully understand how it switched on. In 2024, researchers finally cracked the code. They discovered the exact mechanism that allows PINK1 to activate inside human cells. Why does this matter? Because if we can develop drugs that switch on PINK1, we may be able to protect dopamine cells before they die. Instead of replacing lost cells, this approach could shield the ones we still have. Think of it like installing a fire alarm in the brain, an early defense system that keeps cells safe from the slow burn of Parkinson's. It's still in the lab stage, but scientists are already searching for small molecules that can activate PINK1 in living humans. For those with Parkinson's or at risk of it, this could be a true disease-stopping treatment. Now let's talk about something with a catchy nickname, GDNF, or glial cell line-derived neurotrophic factor. I like to call it brain fertilizer. Just as fertilizer nourishes plants, GDNF nourishes dopamine neurons. It helps them grow, repair, and survive. In the early 2000s, small clinical trials in the UK made headlines when patients who received GDNF infusions showed striking improvements. But later studies had mixed results, partly because it's difficult to deliver GDNF to the right part of the brain in the right dose. Today, the science has advanced. Instead of pumping GDNF directly into the brain, researchers are testing gene therapies. These therapies insert DNA instructions into cells, telling them to make their own steady supply of GDNF. Early safety trials show promise, and larger trials are now underway. If successful, a one-time treatment could provide long-lasting nourishment to brain cells, slowing or even reversing progression. Imagine a Parkinson's therapy that doesn't just mask symptoms, but helps the brain heal itself. Sometimes big discoveries come from unexpected places. That's the case with Ambroxol, a common cough medicine in Europe. Scientists found that Ambroxol boosts the activity of an enzyme called GCASE. This enzyme helps clear waste products inside brain cells. Clinical studies have shown that Ambroxol crosses the blood-brain barrier, activates GCase, and appears to improve cell function in people with Parkinson's. A major Phase 3 clinical trial is now underway to test whether Ambroxol can actually slow disease progression. If successful, Ambroxol could become one of the first disease-modifying drugs for Parkinson's, a treatment that doesn't just ease symptoms, but changes the course of the illness itself. And here's the best part. Since it's already an approved medicine for cough, its safety profile is well known. That means if trials are positive, it could reach patients much faster than a brand new drug. Other exciting developments, stem cells PINK1, GDNF, and Ambroxol are the stars of Parkinson's research right now. But they're not the only ones. Adaptive deep brain stimulation, a smarter form of DBS that adjusts stimulation in real time, based on brain activity. This could improve results and reduce side effects. Nanotechnology, new drug delivery systems that cross the blood-brain barrier more effectively, getting treatments right where they're needed. Early detection, blood and spinal fluid tests that may reveal Parkinson's before symptoms appear. This could open the door to treating the disease before it causes damage. Each of these advances brings us closer to a world where Parkinson's isn't just managed, but truly controlled. Now comes the big question. How close are we to curing Parkinson's? Here's the honest answer. We're closer than ever before, but not there yet. Stem cell therapy shows real promise, but is still in early trials. Pink. One discoveries are brand new, but could be game-changing. GDNF gene therapy is safe, but needs more proof. Ambroxol is the furthest along, with late-stage trials that may deliver results within just a few years. So no single cure exists today. But for the first time, we're moving beyond simply managing symptoms. We're testing real strategies to slow, stop, or even reverse Parkinson's. That's a massive step forward. Parkinson's research is advancing faster now than at any point in history. Every breakthrough, whether it's stem cells, protective proteins, nourishing factors, or even a humble cough syrup, brings us closer to the day when Parkinson's no longer robs people of independence. For those living with Parkinson's today, this progress means hope. Hope that tomorrow's treatments will be more powerful, more protective, and maybe even curative. So how close are we to curing Parkinson's? Closer than ever before. And every year, every trial, and every discovery brings us another step toward that goal.